recording right now. So the sine of 24 degrees, just to go over what we did before I forgot and put in the recording. Among the things, we look for the word degree right up here. And if it's not there, we go to the mode button. And you have to go down and highlight the word degree and then hit enter. I have since then also changed it because we have several problems in a row that ask for answers to the nearest hundredth. I have changed floating point to round to 2 decimal places, and that shows up here. Instead of saying the word float, it says fix 2. It's fixing it at 2 decimal places. And if you're wanting to do that, if you're needing to have answers rounded to the nearest hundredth consistently for several problems in a row, that's a handy thing to know how to do. So with it like that, then the sine of 24 degrees, when I'm sure I'm in degree mode, is going to be just type in the sine function in the number 24 and hit enter. And we had done that before I put it in 2 decimal place mode, and it gave me a long value, and then that value is rounded to 0.41. And so if we go in here for this first answer, we're going to put in 0.41. I think I said it where if you typed in 0.41, it would also give you the correct answer. It would accept it. What about the secant of 72 degrees? How do I find the secant of something? The calculator doesn't have a secant button. So what do I do, Lucas?
1 divided by the cosine.
Right. So secant is 1 over cosine 72 degrees because cosine was equal to adjacent over hypotenuse, and secant is its reciprocal, hypotenuse over adjacent. So you can take 1 over the cosine of 72, or another way you could do this is take the cosine of 72 degrees and raise it to the -1 power. So on the calculator, I can either do this, 1 divided by cosine 72, and I get 3.24 at the 2 decimal places. Or I could take cosine of 72, get that answer, and then say, give me the -1 power, hitting the x to the -1 button over here that just turned red. And I get that same answer. Or I could take the cosine of 72 degrees, close the parentheses that it says, okay, now you're done, you told me the angle, and then I could take that and hit the -1 power button, and that says take the reciprocal of the number cosine of 72, and I get the same answer. And if I didn't have it, if I had it in floating point, it would agree out to all the decimal places that it shows. So what I get out to 2 decimal places is 3.24. And so on here, I'm going to go in and type 3.24, and we're going to hopefully find out that that's the correct answer. And then we get to the problems where a lot of people have really kind of been struggling, and where most of the questions have come up. So this problem, you're told that FH is 14 yards, and you're asked to find FG, which is this side. Now, with all of these problems, kind of the flavor of the problem is you're given one side and one angle, and you're asked to find the length of another side. And the idea is to phrase the problem.
Okay, sorry.
The things we record. So, to phrase the problem in terms of trig functions of some angle, so trig ratios of some angle. I keep using the word function. At this level, I really want to say trig ratio. So, that blue side that I'm trying to find, how does it relate to the 65 degrees? Or what side is that in the triangle? Is it a leg or a hypotenuse or what? Okay. So, first of all, the one I'm trying to find, FG, is the hypotenuse. So, I'm looking for a ratio that involves hypotenuse. And then if I'm going to focus on the 65 degree angle, what is the 14 yards? Is it adjacent or opposite?
Adjacent.
It's adjacent. So I need ratios that involve adjacent and hypotenuse. So I could either take cosine, because we remember that cosine is adjacent over hypotenuse. Or I could take the reciprocal of cosine, which is the secant. So I could either look at using the idea that the secant of 65 degrees is equal to the hypotenuse divided by 14, and then I could try to solve that for the hypotenuse. Remember, I have to then be able to compute that secant function also, or that ratio. Or I could set it up with the cosine. So if I do it this way, the algebra is easier because all I've got is something I'm trying to find. When I divide it by 14, I get secant of 65 degrees. That looks like a complicated thing, but secant of 65 degrees is just a number. So what I can do here is, how do I undo division by 14?
Multiply.
I multiply by 14. So if I multiply, and I always have to do the same thing on both sides of the equation, I'm left with the hypotenuse is equal to 14 times the secant of 65 degrees, which is 14 times 1 over cosine of 65 degrees. So what I get is that the answer should be 14 divided by cosine of 65 degrees. So that's one way to go about solving this. If you had done cosine instead, you would have written cosine of 65 is equal to 14 over the hypotenuse. And now you've got to get the h by itself, so you can multiply both sides by h. And you've got to get rid of the cosine of 65, so you can divide by that. And now you get h on the left is 14 divided by cosine. Yeah. The answer comes up the same way either way. And so here's a couple of issues I want to bring up. First of all, I'm going to go back into floating point mode just to be able to see how the numbers work out. Some people will do this. Let me clear the key press history. Some people have a tendency to say, well, I want 14 times the cosine of 65 degrees. Let me take the cosine of 65 and get that answer. And then they say, okay, that's about 0.42. And so then they come in and they say, let's take 0.42 times 14. And they get 5.88. Now, what's wrong with that?
You're rounding it before it's even
I rounded unnecessarily. Over here, pretty early in the problem, I took this number that I had out to 10 decimal places, and I said, let's throw away all of this information. Now, I want my final answer rounded to the nearest 100th. But that doesn't mean I want to round everything leading up to it to the nearest 100th. Now, the 14, okay, is given to me. I only have 2 digits of that. With the cosine of 65, we can get that to as many decimal places as we need, really. So what I really need to do is let the calculator do what it does well. Take the cosine of 65 times 14. Now, what's wrong with this answer?
You didn't close the parentheses.
I didn't close the parentheses. This says not take the cosine of 65 and multiply that answer by 14. It says take 65 times 14, get that angle, and find the cosine. In this case, it gives me a negative answer. That's not a good thing. So, wait. But I wanted 14 divided by cosine of 65, didn't I?
Yeah, but so doesn't matter.
Yeah, the issue would still be the same, right? If I take 0.42, or if I take 14 divided by 0.42, if I round the cosine and then do the division, I get 33.33. I thought this answer looked kind of way, way far from where it should be. So what I should have been doing all along is dividing 14 by cosine of 65. That's what we calculated the answer should be. If I round it, I get this. But if I let the calculator do what it does really well, 14 divided by cosine of 65, I find out that while the answers are really close, by rounding the cosine to 0.42 and then doing the division, I'm not going to be accurate to 2 decimal places. I'm not even going to be accurate in the first decimal place. That rounding early in the problem made me off by about a little over 2/10 from what the actual answer ought to be. So let the calculator carry along all those decimal places for you as a take-home lesson here. If you are required to get an answer accurate, like in IXL, to a specific number of decimal places. In this case, on my quiz, I wrote it so that it looks at your answer, and I put 3 answers that would be correct. This one rounds to 33.13. I thought that if you did rounding in a not too horrible way and got 33.14 or 33.12, I would have it count those 2 answers correct. So basically, I let it count either any of those 3 answers as correct. But if you didn't match one of those 3, it counted it as incorrect. So I divide 14 by cosine of 65. I don't find the cosine and then round it. If you insist on finding the cosine, rounding it, and doing the computation, round it to a lot of decimal places, like 7 or 8, if you need 2 in your final answer. But the better thing is not to round until you get to the final answer. So there's that one. We think the answer then is 33.13, and we come in here and say the answer should be 33.13, which, by the way, I don't remember really what any of these answers are. You should check for reasonableness. So one of the things that happens a lot is, suppose I got an answer like 11 instead of 33. Could you recognize 11 as being impossible?
Yes.
Why?
Because it's smaller than the adjacent. The adjacent's usually smaller.
Yeah, the hypotenuse has to be the longest side of the triangle. It's got to be longer than both of the legs. And so if you got an answer smaller than 14, it can't be the right answer. Of course, recognizing negative 0.9 is the wrong answer is also, the answer can't be negative. So looking at it, the 33.13, I can't promise you it's right, but at least it's not obviously wrong. Okay, if it's wrong, it's not going to be the case. Like 11, if you put 11 here, that's obviously wrong. The answer's got to be bigger than 14. If the picture's at all to scale, you figure the answer's quite a bit bigger than 14. It's more than twice the length of that. But that's assuming that the angle, that the picture's actually to scale. You can tell this one probably is, because I've got GeoGebra drawing the picture, and the labeling here was automatic, and so I had it measure the angle. This really is to scale. If that's 14, then you could estimate this. A lot of times on tests, pictures will say, not to scale. Okay. Why does that not like the erase rolls? Oh, good. If you think the diagram is to scale, then you could probably just come over here and say, just by touching a couple of points about that far apart, or making a mark as long as this FH, and then on a piece of paper, and then laying it out on here, you'd say this is at least twice that long, and then some. So the answer ought to be bigger than 28, and that's a good estimate. You can also look at this and say, well, I know that if this were a 30-degree angle, because you see it's really a 25-degree angle, if it were 30, the hypotenuse would be twice the 14. It would be 28. This is a little bit smaller than 30, which probably makes this a little bit longer than 28, and 33 is a reasonable answer from that point of view. How about this one? I think this might actually be easier than the last one.
Yeah, it is.
What are we asked to find?
Yes.
Okay, so let's give that a name. Let's call it X. We've got an angle, and we're given that side. So what trig ratio is suggested here?
Sine.
Yeah, sine, because relative to 52 degrees, x is the opposite, and this is the hypotenuse. And we know that sine is opposite over hypotenuse. So either sine or cosecant would be reasonable. You probably want to stick with sine if you can, because it's on your calculator. You've got a button for it. And so the sine of 52, we know that x, the opposite, divided by 47, the hypotenuse, is the sine of 52 degrees. And so I've had a lot of students really struggle with something like this. So if I had asked you instead if x divided by 5 was equal to 7, could you solve that equation?
Yes.
Okay, this goes back to very beginning algebra. This is a one-step linear equation in one variable. Okay, so we have to go back and not forget all the algebra that we learned last year. This, I can think about undoing division by 5 by multiplying. The idea is the same here. X divided by 47 is equal to a number. Now that number is not pretty like 7. It's the sine of 52 degrees, which is really, really long and complicated. But if I multiply both sides by 47, then the 47's cancel here, and x is the sine of 52 degrees times 47. Now, I need my calculator to get that. So if I take the sine of 52 degrees times 47, sine 52 degrees times 47, I get negative 0.97. I'm going to get an answer that's really unreasonable. It turns out the sine ratio is always between -1 and 1. And so I'm not going to get an answer that's big enough, because if I look back at that picture, even if that were a positive number, that's not the picture, this is the picture. This side's 47. Do you believe x could be less than 1? Would that seem reasonable if you got an answer even like positive 0.9? Because this angle, 52 degrees, is a little bigger than 45, but we know in a 45-45 right triangle, if this were isosceles, the two legs would be comparable in length. They'd be exactly the same length. This is a little bit bigger than 45 degrees, so angle G is a little bit smaller than 45 degrees. So these two sides, though, ought to be comparable in length, and 47 ought to be something like the square root of 2 times x, in that order of magnitude. That's just a really rough ballpark estimate. But
You forgot to close the...
yeah, so when I look back over here, the problem is, because I've gotten sloppy about when I compute sine of 52, I get out of the habit of closing the parentheses, and it doesn't matter. Well, here it matters. This says, take the angle 52 times 47, and then find the sine ratio for that angle. What I really wanted it to do was take the sine of 52 degrees, and then take that result and multiply it by 47. And that gives me 37.04 for an answer when I round it to 2 decimal places. So that's going to be 37.04 rounded. Lovely. So I go back over here, and I'm going to type that in. Now, that doesn't prove to me that that answer is right, but it's at least in the right ballpark. I do a quick check. It ought to be bigger or smaller than 47?
Smaller.
47 is the longest side of the triangle. The two legs both ought to be smaller. If I'd gotten an answer like 52, I'd say, oh, wait, I did something wrong. But here, I got 37.04. I'm going to put that in as my best estimate of the answer, 37.04 to the nearest hundred. Questions on that? It begins by looking at what I'm trying to find and what I'm given, and setting up a trig ratio based on that for whatever angle I'm given. And then I just have to go through and solve for the thing I don't know in terms of the stuff I do know. I'm going to stop that video recording right there. So let me come in here and